The National Electrical Code, or NEC, generally does not mandate ground fault circuit interrupter (GFCI) protection for existing motors installed before the GFCI requirement's effective date. However, exceptions exist. The NEC does mandate GFCI protection for existing motors in specific locations. These include motors used outdoors. Motors used in wet or damp locations also require GFCI protection. Motors used in or around swimming pools and spas necessitate GFCI protection. Additionally, motors used in temporary installations demand GFCI protection. While the NEC doesn't universally require GFCI protection for all existing motors, it is considered a sound practice to install GFCIs on all motors irrespective of their location or application. GFCIs significantly contribute to preventing electrical shocks and fires. Installing GFCIs offers an additional layer of safety. GFCIs detect ground faults. A ground fault is when electrical current strays from its intended path and flows to ground. This can happen if there's damage to the motor's wiring or insulation. GFCIs quickly interrupt the circuit when a ground fault is detected, minimizing the risk of electrical shock. The suggestion to equip the motors with GFCI protection is a valuable consideration. GFCIs provide essential protection against electrical shocks and fires. Implementing GFCI protection on the motors is highly recommended, if feasible. A GFCI works by monitoring the current flowing into a circuit and comparing it to the current flowing out of the circuit. If there is a difference of more than a few milliamperes, the GFCI trips, cutting off power to the circuit. This happens very quickly, typically within milliseconds, which is fast enough to prevent serious injury or death. GFCIs are relatively inexpensive and easy to install. They can be installed in place of a standard electrical outlet or circuit breaker. It's important to choose a GFCI that is rated for the voltage and amperage of the circuit it will be protecting. It's also important to test GFCIs regularly to make sure they are working properly. This can be done by pressing the test button on the GFCI. If the GFCI doesn't trip when the test button is pressed, it needs to be replaced. In conclusion, the NEC doesn't mandate GFCI protection for existing motors predating the GFCI requirement unless situated in specified locations. Nevertheless, installing GFCIs on all motors, regardless of their placement or function, is a prudent safety measure. To elaborate on the NEC requirements, it's crucial to consult the specific edition of the NEC that is in effect in a jurisdiction. Electrical codes are updated regularly, so it's important to stay current with the latest requirements. Section 430 covers motors and motor circuits. Section 430 contains detailed information on motor protection, wiring, and control. GFCI protection requirements are often found in Section 210, which covers branch circuits. Specific requirements may vary depending on the voltage, amperage, and location of the motor. Regarding GFCI protection in damp or wet locations, Article 680 addresses swimming pools, fountains, and similar installations. This section provides specific requirements for GFCI protection of electrical equipment used in these locations. Article 590 pertains to temporary installations. Temporary wiring and equipment often require enhanced safety measures, including GFCI protection. Considering the existing conditions, it's crucial to assess whether the pottery class environment qualifies as a damp or wet location. The presence of water or conductive materials can increase the risk of electrical shock. Implementing GFCI protection in such cases is a proactive safety measure. When retrofitting GFCI protection to existing circuits, it's essential to ensure that the existing wiring is in good condition and properly grounded. If the wiring is old or damaged, it should be replaced before installing GFCIs. It is also necessary to verify that the circuit has adequate capacity to handle the additional load of the GFCI device. GFCI receptacles are available in various amperage ratings. Selecting the correct rating ensures proper protection and prevents nuisance tripping. Circuit breakers with integrated GFCI protection are also available. These offer whole circuit protection. Consulting a qualified electrician is recommended when making decisions about GFCI protection. An electrician can assess the existing conditions, ensure compliance with local codes, and provide guidance on the best approach for implementing GFCI protection. Remember that GFCI protection is designed to protect people from electrical shock. It is not a substitute for proper wiring and grounding. Regular inspection and maintenance of electrical equipment are essential for maintaining a safe electrical environment. Furthermore, consider the specific use of the motors in the pottery class. If the motors are used with equipment that comes into contact with water or conductive materials, the risk of electrical shock is increased. Implementing GFCI protection in these situations is particularly important. Staff and students should be educated about the purpose and function of GFCIs. They should also be instructed on how to test GFCIs and what to do if a GFCI trips. Regular safety training can help to prevent electrical accidents. In addition to GFCI protection, other safety measures should be considered, such as the use of properly insulated tools and equipment, and the implementation of lockout/tagout procedures for maintenance and repair work. A comprehensive safety program can help to create a safe and healthy learning environment. For further clarification on GFCI requirements, consult the latest edition of the NEC and any applicable local codes. It is always best to err on the side of safety when dealing with electrical equipment. Proper planning and installation of GFCI protection can significantly reduce the risk of electrical shock and fire. The student's suggestion highlights the importance of proactively addressing safety concerns. By considering the potential risks and implementing appropriate safety measures, a safer environment can be created for all. It is good practice to periodically review electrical safety practices. This ensures continued compliance with current codes and regulations. Consider consulting with an electrical engineer for a comprehensive safety assessment and recommendations. An electrical engineer can evaluate the electrical system and identify potential hazards. They can also provide guidance on how to mitigate these hazards. The use of portable GFCIs can provide an additional layer of protection for temporary installations or equipment that is not permanently wired. Portable GFCIs can be plugged into a standard electrical outlet and provide GFCI protection for any equipment that is plugged into the GFCI. When using portable GFCIs, it is important to make sure that they are properly grounded. The grounding prong on the GFCI should be plugged into a properly grounded electrical outlet. If a properly grounded outlet is not available, a ground wire can be connected from the GFCI to a nearby grounded metal object, such as a metal water pipe. It is also important to protect portable GFCIs from moisture and physical damage. They should not be used in wet or damp locations unless they are specifically designed for such use. Regular inspection and testing of portable GFCIs are essential to ensure that they are working properly. The test button on the GFCI should be pressed regularly to verify that it is tripping properly. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. The type of GFCI protection needed depends on the specific application. GFCI receptacles are commonly used for outlets in bathrooms, kitchens, and other wet locations. GFCI circuit breakers provide protection for an entire circuit and are often used for outdoor circuits or circuits that serve multiple outlets. It's critical to coordinate GFCI protection with other protective devices, such as fuses and circuit breakers. The coordination ensures that the protective devices will operate properly in the event of a fault. A qualified electrician can help to determine the appropriate type and size of protective devices for a particular application. Grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or GFCI. A properly grounded electrical system can significantly reduce the risk of electrical shock. All electrical equipment should be properly grounded. The grounding conductor should be connected to a grounding electrode, such as a ground rod or metal water pipe. Regular inspection and testing of the grounding system are important to ensure that it is working properly. Surge protection is another important aspect of electrical safety. Surge protection devices (SPD) protect electrical equipment from voltage surges which can be caused by lightning, power outages, or other events. SPD divert excess voltage away from sensitive electronic equipment, preventing damage. SPD are available in various types and sizes. They can be installed at the service entrance, at branch circuits, or at individual pieces of equipment. It's important to choose SPD that are properly rated for the voltage and current of the electrical system. Regular inspection and testing of SPD are important to ensure that they are working properly. Arc fault circuit interrupters of size are another type of protective device that can help to prevent electrical fires. ASIs detect arc faults, which are dangerous electrical conditions that can cause fires. ASIs trip the circuit breaker when an arc fault is detected, preventing the fire from starting. ASIs are required in many new homes and are often recommended for older homes as well. Electrical safety is a shared responsibility. Everyone should be aware of the potential hazards of electricity and take steps to prevent electrical accidents. By following safe electrical practices, injuries and fatalities can be prevented. Always assume that electrical wires are energized. Never touch a downed power line. Call the utility company to report downed power lines. Use caution when working near electrical equipment. Wear appropriate personal protective equipment (PPE), such as rubber gloves and safety glasses. Never overload electrical circuits. Overloading can cause the wires to overheat and start a fire. Use extension cords safely. Do not use extension cords as permanent wiring. Do not run extension cords under rugs or furniture. Do not overload extension cords. Keep electrical equipment dry. Water conducts electricity and can create a shock hazard. Do not use electrical appliances near water. Have electrical equipment inspected regularly by a qualified electrician. An electrician can identify potential hazards and make recommendations for repairs or upgrades. When making electrical repairs, always disconnect the power before starting work. Use a voltage tester to verify that the power is off. Follow the manufacturer's instructions when installing or repairing electrical equipment. If you are not comfortable working with electricity, hire a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. By following safe electrical practices, injuries and fatalities can be prevented. To further enhance safety in the pottery class, consider implementing the following measures. Firstly, ensure that all electrical outlets are properly grounded and in good working condition. Replace any damaged or worn outlets immediately. Secondly, use only approved extension cords that are rated for the amperage of the equipment being used. Avoid using multiple extension cords plugged together. Thirdly, keep all electrical cords away from water and other liquids. Wipe up any spills immediately. Fourthly, never overload electrical circuits. If you are using multiple pieces of equipment on the same circuit, make sure that the total amperage does not exceed the circuit's capacity. Fifthly, inspect electrical equipment regularly for damage. Look for frayed cords, cracked housings, and other signs of wear. Replace any damaged equipment immediately. Sixthly, provide adequate ventilation for electrical equipment. Overheating can damage equipment and create a fire hazard. Seventhly, install smoke detectors in the pottery classroom. Test the smoke detectors regularly to ensure that they are working properly. Eighthly, have a fire extinguisher readily available in the pottery classroom. Make sure that everyone knows how to use the fire extinguisher. Ninthly, conduct regular safety training for all students and staff. The training should cover electrical safety, fire safety, and other relevant safety topics. Tenthly, develop an emergency plan that outlines the procedures to be followed in the event of an electrical accident or fire. Make sure that everyone is familiar with the emergency plan. By implementing these measures, you can create a safer environment for all students and staff in the pottery class. Remember that electrical safety is an ongoing process. It requires vigilance and attention to detail. By staying informed about electrical safety practices and following the recommendations outlined in this guide, you can help to prevent electrical accidents and protect yourself and others from harm. Moreover, regular audits of the electrical installations and practices can help to identify potential problems. These audits could be done by someone certified in the electrical industry or by a certified safety professional. The audit should document any issues and ensure they are addressed in a timely fashion. It is a good idea to keep records of any inspections, maintenance, repairs, and safety training. Such records demonstrate a commitment to safety and can be valuable in the event of an accident or incident.